Good evening. I apologise if this sounds slightly unprepared. I had a slightly nightmare day, so rather than spending the afternoon preparing and rehearsing this presentation, I spent it fighting device snapper and all kinds of other fun instead. But anyway, tonight I'm going to tell you to encrypt all the things in Amazon Web Services. And there you are, I've said it. Good night. Okay, so I do actually have a presentation to talk about. I've worked for the last 10 years for Clarinet as a systems engineer. Juiced, which was a startup doing TV over the internet, where I ended up managing the ops team. Betfair, where I headed up the performance and capacity teams. Expedia, where I was operations architect, responsible for performance, automation, and the cloud. And now at Project Florida, which is a tiny startup where I am the whole ops department. Security's not always been my main focus, but it's always been part of everything. For example, when Betfair was hacked in 2010, I led the forensic analysis to investigate who it was who hacked us and how they got in. So security's been important to me, and it's becoming more so, particularly in my current job. Sorry, I forgot to mention, so I'm now, actually, sorry, never mind, ignore me. So what's this talk about? I kind of wish it was about puppies, because they're kind of fun, and they're always happy. And that's my girlfriend's dog up the front there. What the talk is really about is ways that you can integrate security into your infrastructure, rather than always having to think about it at the app level, and thus right at the last minute before you go to production, or when you're doing a PCI audit, or something like that. This is meant to augment other work. It's not meant to replace other work at all. So it doesn't really replace it, it just augments it and adds to it. Why should you care about this? Well, on the left you've got a bunch of companies who you probably realise over the last couple of years have been hacked. Sony features twice, both for the PlayStation hack in 2011 and their more recent one, which was that movie, The Interview. And so there are lots of other companies I could put up there. These seem to be the most high-profile ones I could find. And then on the right, thanks to Mr. Snowden, we know about the NSA and GCHQ sort of listening to anything they can and logging it and using it for profiling purposes. And on top of this, a lot of the time the companies get breached, they don't bother announcing them because their lawyers will argue that it's not really materially significant and therefore they don't need to tell shareholders or stakeholders about it. For example, at Betfair, they were hacked in 2010, but it only made the front page of the Telegraph in September 2011, so that was 18 months after the event. So when I was at Expedia, I was involved in a data classification project to determine what it was we could take to the cloud, because at the time Expedia was hosted solely in their own data centers, and they were moving everything. They wanted to move everything out to Amazon, to Rackspace, to Google, and other cloud providers. But before we could do so, we had to identify what data we could reasonably argue is safe enough to store in someone else's data center. So we started off public information. This is stuff like, for example, images and things like that, which are on a website. Those can go out there because they're already public, and if someone has a copy of them, it's no big deal because they can just download them from Expedia.com. Then we determine there's company confidential data. This is stuff which could cause potential embarrassment, perhaps the leaking of a product roadmap, or like knowing when the next iPhone is going to come out a week early. Cause embarrassment, but not material damage to a company. Then you've got intellectual property information, things like where source code or product designs get leaked, or blueprints in the case of Lockheed Martin for the F-35 Joint Strike Fighter. If those get leaked, they're going to have a real impact on the company, and their share price might fall, or people may stop trusting the company so much. But none of these are really actually important. What's really important is the data of you and me, the customers of all these companies. And mostly, there's three main parts of this, and they all take, for some reason, they all end up with a three-letter acronym in the form of P something I. So thinking of PI, Magnum PI came to mind, so I apologise for that. So this is personally identifiable information as PII. This is things like your name, your address, perhaps your relationships, your likes, dislikes, things like this. This information can be used to steal your identity and for someone to impersonate you. And obviously you care quite a lot about this data, but if a company's hacked, for example, I think when Sony were hacked, they offered people an identity protection service for a year. So you're kind of protected against that. There's an insurance available for that. So it's bad, but it's not the end of the world. Next up, PCI, which, hands up if you've been through a PCI audit here. Okay, so quite a few of you. They're lots of fun. So PCI stands for payment cardholder information. And if a company gets hacked and their credit card information gets leaked, the general process is that you'll contact the bank. The company will talk to their bank, they'll talk to their lawyers, and generally speaking, the banks will talk to all the cards that have been through the system during the period in which it was breached, and then suddenly all the company's customers will start getting new debit cards or credit cards in the post, and told that they were being replaced because a company got hacked. And most of the time, you won't be told which company it was and why. So again, it's pretty bad if this kind of data gets leaked, but as an individual, your bank covers you for your losses, so it's not really the end of the world. So lastly, I'm not sure if this is a term that's familiar in the UK, but I'm working in New York these days, and it seems to be a common term over there. It's PHI, which is Protected Health Information. Often there's an E attached to the start of it, in that it's electronic protected health information. This is stuff like your medical records. It's very important because you can't really be issued with replacement body parts, or not yet anyway. So this kind of data is it's really important. It's really important to protect because you need to make sure that it doesn't get stolen in the first place. And the regulations around this give you as a company who are holding this kind of data huge penalties if you're compromised, if you leak this information out. So in terms of best practice around this, there are hundreds of books available on this. Here's a selection of them. On top of that, there's regulations and organisational security policies, which run to hundreds of pages as well. There's basically what I'm trying to say is there's many facets to security. And tonight I'm only going to talk about one of them, which is encryption. So, and particularly that, I'm talking about encryption in AWS, because that's where we're hosting all our services at Project Florida. So, data encryption. If you do it with Amazon's electronic block store, which is their block level device, think of it like a hard drive, you can enable, as of a couple of years ago, you can enable encryption as a checkbox when you create the device. It's a free option, it doesn't cost anything, and it has virtually no performance cost. And it just means that if the event that the server that's hosting your data, if the disks from it were taken, the data in it, rather than being clear text, will be fully encrypted, and thus someone with access to the system will not be able to recover them. Similarly, with the Amazon S3, there's an option you can pass. It's slightly annoying how you can enable it. You can set up a bucket policy to require server-side encryption, but then every time you upload upload some data, you need to pass a header to say this piece of data should have server-side encryption. But with these, again, essentially what it gives you is it gives you protection against the device security, against the physical device being, someone having access to the physical device. Of course, within your databases, you may wish to encrypt some other data as well. For example, if you're storing credit card data in a database or perhaps on passwords, you probably should hash those or encrypt them. But this gives you added protection, and it's basically free, so there's no reason not to do it. So this is actually the point of the talk, network encryption, and I apologise for taking a few minutes to get here. So when I talked about PCI earlier, I think most people here will know from PCI regulations that any transaction going to or from a credit card that are associated with customer payment card information needs to go over encrypted links. Generally speaking, when people talk about this, they call it SSL, Secure Sockets Layer. Well, Secure Sockets Layer is dead. It's now called, because the SSL v2 and SSL v3 protocols have been shown to be very insecure, and so with vulnerabilities out there in the wild, if you're using TLS, no doubt you end up with certificate management hell. I don't actually use Windows, but the screenshot from OpenSSL for doing a certificate request was not as pretty as the Windows dialog there. And at Expedia, for example, we had dozens of services, each with SSL certificates within them, and often we're using a client certificate on the where one service is talking to another service. We're often using both client and service certificates to do authentication there as well. And one of the problems with this is when you've got hundreds of certificates, managing them becomes really difficult. And for example, at Expedia, we had a number of multi-million-dollar outages due to cert expiry on some old legacy servers that everyone's forgotten about. It becomes a real pain and affects customer confidence. On top of that, this is a packet capture from TCP dump earlier today on a server. You can see most of the traffic in there, in the green, is over plain HTTP. And in fact, you can see a GET request to some forum page. But then you see a request down the bottom, which is the one in blue, which I highlighted to make it even more obvious than it was otherwise. But that, you can see the protocol there is TLS version 1.2. Now, the reason why someone might be seeing this is because I mentioned that certificate management is a pain in the proverbial. You only do it where necessary. And therefore, you only protect the data you care about. But that also means for someone who's snooping traffic on some system, they're able to see the endpoints between which important information is being transmitted, because why else would you be encrypting it? So based on this, you're actually leaking information because you're, for someone who's perhaps interested in finding where the most valuable information on your system is, you suddenly told them where it is because you know it's going to be between those two hosts. It's either on one host or the other host because they're talking about it. Because why else would you be using encryption? So this got us thinking about what can we do that's different. What if we didn't use TLS for this? What if we did something else? What about IPsec? So when I talk about IPsec, I imagine most of you probably think of where you're connecting to a VPN in the office, and you're connecting to some kind of expensive Cisco or Juniper network device. And no doubt you have to install some Java clients and it doesn't work very well and you have all kinds of problems. I'm not talking about that. I'm talking about doing host-to-host IPsec between every single device on your network, or in our case, every single one of our EC2 instances. Because then when you do your packet capture, all you can see between one host and all these other hosts it's talking to is the protocol of ESP, which is the encrypted secure payload that you get with IPsec. So for someone wanting to snoop and find out the interesting stuff on my network now, they can't see. They just know that I'm using ESP everywhere. So we thought, well, no, this seems like a no-brainer, we should do it. What's the cost of it? Well, on a couple of Amazon instance types, the M3 Medium and the M3 Extra Large, there's basically zero penalty from a performance perspective. On the M3 Medium host, we got exactly the same numbers of 326 megabits a second between two hosts. On the M3 Extra Large hosts, we were able to do 1,020 megabits per second without encryption, and 1,010 megabits a second with encryption. This is negligible from our perspective, and it's down to Intel's new AES new instructions, which they built into their latest processors. So as long as you're using Amazon, the M3 generation or newer instances within Amazon, you can use encryption and not pay a performance penalty. Because the CPU cost of this is less than 3%. So unfortunately, unlike the Elastic Block Storage and S3 encryption I mentioned earlier, where you've got a checkbox within Amazon where you can just tick the box and have encryption out straight away. You can't do that with IPsec. You have to do it a bit yourself. We use configuration management to work around this. In our case, we're using Chef, although Ansible or Puppet would do as well. We just do a search across our environment to pull out all the hosts that we should be doing encryption between. And then within the template, we first of all define a bunch of common settings, and then for each pair of endpoints, we create we create the configuration. It's fairly neat, although between, if you've got lots of hosts, you end up with quite a large configuration file. And I should note as well that we are using a certificate authority here. We do still have a little bit of cert management pane. But rather than having 10 or 20 certificates per host, we're down to just one. So it's a significant improvement from that perspective. And we configured it just to trust any, at the moment, because we're still testing, we can configure it to trust any certificate within our, signed by our authority. You could actually change that if you wanted to make it more restrictive. So from that perspective, the performance is pretty good. Well, it's excellent actually. And the configuration is not too hard. So we're almost there, aren't we? In that we've deployed it to dozens of hosts without issue. We've generated the configuration, the tunnels come up, and it just more or less works. But there are some caveats with this. And the first one is, well, the first two are kind of like the things that actually make IPsec good and what we want to do, because they stop information leakage. They actually make life harder as well. Because, for example, within Amazon, you've got security groups. Think of these like VLANs or something else on a conventional network. And normally you can set restrictions between these security groups where, for example, you can allow traffic through on port 443 or 8080 or whichever. But with IPsec, you can't do that anymore. You have to, you can allow traffic between one host and another host, but if you allow any traffic, you allow all traffic. So you have to do firewall management on the host itself using IP tools or similar. On top of that, some tooling like TCP dump, I showed you already, it becomes less effective. So when you're debugging, you potentially got more things that you need to look at. But then when you have the same when you're using TLS anyway, if you can't just TCP dump and view the flow of requests in a TLS session, at least not if you're using perfect forward security. So, and furthermore, there are some other limitations here as well. Some services, like the Docker registry, require TLS anyway, so you end up doing double encryption. That's not really a big thing, but it's something which is a little bit annoying. And on top of that, the non-EC2 AWS services, things like their relational database store or S3, don't support IPsec, so you end up doing TLS for them as well. But and finally, the last kind of limitation that we've noticed so far is that in the past, doing the client certificate authentication in applications meant that we were able to do authentication using that mechanism as well. Now we can't, and so either we have the thing of we just trust the host, which seems rather insecure, or we need to develop a different way of doing authentication. So, in summary, and I've kind of rushed through the slides a little bit here, so I apologise if things weren't fully clear. But by going down the route we've gone to, that we've chosen, we're protecting against accidental information leakage. We're not suffering any performance penalty, and so in total it seems to be a fairly sensible thing to do. The only thing is, and I was chatting to someone beforehand who separately had come to the same conclusion that it seemed to be a good idea, but there's no one talking about it. So, so there's no one talking about doing it. People don't seem to be doing it, but the developers for LibreSwan, the most common IPsec library out there, seem to think it's a good idea for us when I've talked to them in IRC. So, I don't know, what do people think? And that's the end of my talk. Thank you very much.
Any questions for Andy? One at the back there.
So you talk about using Chef to set up all the tunnels, and you're getting very large configuration files. Have you not considered using opportunistic encryption, where the keys are just in DNS and it just does it magically?
That's a great question. So the question was, in case it wasn't heard for everyone else, did we consider using opportunistic encryption? At the moment, I'm going to call it OE because I struggle with the pronunciation otherwise. At the moment, OE is disabled by default in most common IPsec stacks because there were some security vulnerabilities within it. It's currently being redeveloped. I was chatting to Paul Wouters from LibreSwan a few days ago. He reckons the next few months that will become an option, and hopefully, so yeah, we'll look to it in the future.
And a follow-up from that is that when OE does work, and if you've got DNSSEC, that can solve a lot of the authentication problems as well, because you can use the DNSSEC, so you know that DNS is secure, so you know that everything is kosher.
Yeah, no, I completely agree. When it works, it'll be great.
Yeah.
Any other questions? Jonathan.
So you're cherry picking your pairs of hosts that you're going to have encryption going between. That seems to be leaving the potentially accidental leak of information later if you forget to do a pair of hosts to be quite a big problem, because you turned off your TLS for this service because you don't need it anymore. Is there a point at which you're going to say, we're just going to firewall all non-IPsec traffic off these boxes, and when do you solve problems like going to, as you say, non-EC2 services like packet updates?
Okay, so there was kind of a couple of parts to that question. So the first thing we're doing in our Chef environment, in the Chef search, we're searching for all nodes within a Chef environment at this point. So it's that should be everything a node is normally talking to. In terms of talking to things outside of our environment, we are opaquely proxying every single thing. So we have a vhost configured for Chef, a vhost configured for S3, a vhost configured for every single remote service we're talking to on a proxy server, and that has permissions to talk out to those remote services. Normal hosts do not have direct internet access. I think we're out of time.
Good stuff. Andy Mulholland, thank you very much.